Today we're going to talk about logarithms. So in the first question it says to find the inverse of y equals 3 to the power of x. So remember, this is called an exponential function because we have a variable as an exponent. So we learned in the last unit to find the inverse, we switch the x and the y's. So we get x equals 3 to the power of y, and then we solve for y. Well, in this part, the question is, how do we solve for a variable exponent? Can't just divide it out. I can't multiply it out. I can't add or subtract it. So how do I get this exponent so that it's no longer an exponent so that I can solve? The answer is we use logarithms. So this is a new type of function that we are going to learn today to do. And so if I rewrite this in the form, it becomes the log and the base stays the base. So this is a base 3. So we have the subscript for a log, which is called the base. So this is read log base 3 of, and we take the x that goes here. So log base 3 of x equals y. So notice that the answer to a log is an exponent. So that's why we like logarithms, because it allows us to solve for a variable exponent. So logarithmic and exponential expressions. Logarithm with base b, and we're going to look at the graphic organizer in just a minute. So if I have log base b of y is equal to x, that's if and only if b to the power of x equals y. So that's from one form, which is logarithmic form, to exponential form. So for this equation that we're learning, you read it as log base b of y equals x, and your b and your y both have to be positive, and also your b value cannot be equal to 1. So those are just some rules of the equation, because we can't take the log of a negative number, and we'll talk about that in a little bit. So let's go ahead to our graphic organizer that we have, and let's fill out some of this. So going down here to the bottom, we have the exponential form. So if I have the base, which is b, to the exponent, which is equal to the answer, if I want to rewrite this in logarithmic form, this would be the log, the base stays the base, and remember that's a subscript, so it's going to be smaller, so log base b of a equals e. And so that is right here, written out in the words, log base b, log of the base of the answer equals the exponent. And again, reread it, log base b of a equals e. So why did we do this? The question is, how do we solve for an exponent? And the answer, we said, is use logarithms. Sometimes we also say that the answer, which is right here, so whatever we're taking the log of, that's called the argument. Of the log. So you might hear me say the argument, and so if you do, it just means what you're taking the log of. And on the back side, let's go ahead and practice doing one form to the next. So we have what's called the logarithmic loop trick, which you can use or not use. But if your log and your exponential form is with the log to the left of the equation, then you can draw your loop going counterclockwise. And that's how you go from one form to the next. So if I have the base stays the base, the x becomes the exponent, and a is the answer. So if I want to go from this logarithmic form, log base 2 of 8 equals 3, if I use the loop trick in exponential form, the base stays the base, so this would be 2. The answer to the log is an exponent, so 2 to the third equals 8. So that would be the new form. So I can do the same thing for this next one. 3 squared equals 9. So if I want to do the opposite, go from exponential form to logarithmic form, we could do the same thing. So the base stays the base. This would be the log base 5 of 25 equals 2. Because remember, the answer to a log is an exponent. So for this next one, same thing. Log base 1/3 of 7. Oops, sorry, that's not 1/3. The base is 343. Log base 343 of 7 is equal to the exponent 1/3. And so that is how we go from logarithmic form to exponential form. So let's go back to our notes. So on our notes, see if you can do 1, 2, and 3. You're going from logarithmic equation to rewriting it as an exponential equation. So use your graphic organizer to help if you need it. So for this first one, if we use the loop trick, the log, the base stays the base. So 2 to the power of 5 equals 32. And you could even check in your calculator, is 2 to the 5th 32? Yes, it is. Over here, 7 to the power of 0 is equal to 1. And this last one, 13 to the power of 1 equals 13. So now go ahead and do the next 4, 5, and 6 problems. Take the minute to pause the video and then unpause it when you're done. So for question 4, if we loop it around, the log, the base stays the base, so it's 1/2. And remember, it's a subscript, so it should look smaller. So log base 2, so excuse me, log base 1/2 of 2 is equal to -1. For this one here, log base 5 of 125 equals the exponent 3, and log base 8 of 2 equals x. And again, if we need to refer back to our graphic organizer, this is what we're doing right here. We're going from the one form to the other. The base stays the base, the exponent becomes the answer, and then the answer becomes what you're taking the log of. So let's go ahead and do this next part. It says solve for x. So here we have 2 to what power equals 2? Well, we know that 2 to the first power equals 2, so x would be equal to 1. 2 to what power is 3? We might not know, so let's go to the next one. 2 to what power is 4? We know that x is equal to 2. 2 to what power is 8? So this would be x equals 3. Let's say you didn't know. You could also use your graphing calculator to help you figure these out. So in your graphing calculator, go to your y equals. And in your y equals, plug in 2 to the power of x. And when you do that, you can go to your table. So second graph is your table. I'm going to have to start this at 0. And you can see, so if I do 2 to the first power, I get 2. 2 to the second power is 4. 2 to the third is 8. We can see 2 to the fourth would be 16. So this would be x equals 4. So what happens when it is not one of the numbers in my table? So like, how do I solve 4 to the x equals 3 or 2 to the x equals 10? So the way that you would solve that is you would look to see, well, 3 is in between 2 and 4, which is an x value of 1 and 2. So you know that this x value has to be in between 1 and 2. And so you can just guess and check, and you can kind of make some connections. I would notice that 3 is in the middle, so I'm going to try to do 2 to the 1.5. So in my calculator, if I do 2 to the power of 1.5, enter, notice I get 2.8. So then I would try 2 to the power of 1.6. So it's a little bit of guess and check. And I get 3.0. So that tells me that I'm probably going to use 2 to the 1.6 as my answer. So 1.6 would be for x. So 2 to the power of what gives me 10. So again, if I go back to my table, I can see that 10 is in between an x value of 3 and 4 because we have 8 and 16 here. 10 is closer to 3 than it is to 4. So when I do my guess and check, I'm going to try numbers closer to 3. So we have 2 to the maybe 3.2. And let's try 2 to the 3.3. And 2 to the 3.4. So it looks like 2 to the 3.3 or 3.4 you could use as your answer. So I'm just going to say about 3.3. So x is about equal to 3.3. So for the next one, same thing. 2 to what power is equal to 1/2? So how do I get a fraction? Well, we have to remember our properties of exponents. Remember that when I have negative exponents, I get fractions. And if I look at my table, notice that -1 gives me a 1/2 because really this is saying 2 to the -1 is equal to 1 over 2 to the first power. So that means x equals -1. Looking at the next problem. So now we're going to evaluate the logs using our answers that we just did. So if I have log base 2 of 2, I know that the log base 2 of 2 is equal to 1. And the reason I know that is because if I rewrite this in exponential form, this would be 2 to what power equals 2? Well, I know 2 to the power of 1 equals 2. Same thing with the next one. We would say, because we're trying to solve for x, let's say, so 2 to what power equals 3? Well, we just said in the last problem over here that it's 1.6. Use a different color. So then 2 to what power equals 4? So for this one, I would say that 2 to the, and we have to figure out then that this would be 2 squared, because 2 squared is 4. So 2 to what power is 8? We know that 2 to the third power. So log base 2 of 8 equals 3. Log base 2 of 4 equals 2. Log base 2 of 3 equals 1.6. So 2 to what power is 16? So that means the answer to this log would be 4. And 2 to what power is 10? The answer to this would be equal to 3.3. So again, we use exponential form to help us evaluate our logs. So let's look at this next column. Now notice that our base is not 2, but we have a base of 3 instead. So if I do a base of 3 and solve, 3 to what power is 1? So remember, anything to the 0 power is 1, so this would be 0. 3 to what power is equal to 3? So this would be an x value equal to 1. 3 to what power is 5? So again, if it helps, you could always use your graphing calculator. And in your y equals, if you plug in now 3 to the power of x and hit your table, notice that 5 is in between an x value of 1 and 2, and 5 is closer to 3 than it is to 9, so it would be closer to the x value of 1. So let's go ahead and do our guess and check now. So 3 to the power of, let's do 1.3. And then 3 to the power of 1.4. And 3 to the power of 1.5. So 1.5 gives us 5.19. So I'm just going to go ahead for this one and say about 1.5. You could also say 1.4, but since 1.5 is closer, I'm going to use that. And then 3 to what power is 9? So for this one, we know x would be equal to 2. So we use this idea of exponents to help us solve for logarithms because the answer to a log is an exponent. So that's what we're going to be doing in this next part. So in this next part, we're going to evaluate each expression, and we're going to use exponential form to help us do so. So here's an example for the first one. We have log base 3 of 3 equals what? So I'm going to rewrite this in exponential form to help me. I'm just going to put an x here. So 3 to what power equals 3? Well, we know that then the exponent would have to be an exponent of 1 because 3 to the first power equals 3. So that means that the answer to this log would be, oops, not 3, would be 1. So go into the next one. Same thing. 3 to what power is equal to 9? So then we know that 3 squared equals 9, so the answer to this log is 2, because remember the answer to a log is the exponent. So the next one, if we have 3 to what power equals 1/3? So remember, to get fractions when you're dealing with exponents, you have to have a negative number. So I know that 3 to the negative 1 equals 1/3. Why don't you see if you can do D and E on your own, pause the video, and when you're done you can unpause to check your work. So for the next one, 3 to what power equals 1? So that I know that this would be 3 to the 0 power equals 1 because anything to the 0 power is 1, so 0. And 3 to what power equals 1/9? So notice it's a fraction, so I know that my exponent has to be negative. So when I'm doing this, 3 to what power gives me 9? I know 3 squared is 9, but to make it go in the denominator, it has to be negative. So 3 to the negative 2 is equal to 1 over 3 squared, which is 1/9. So negative 2 would be the answer to this log. So let's go ahead and look at the next one. Log base 3 of 81. So I'm going to use exponential form to help me solve. 3 to what power equals 81? And again, if you're unsure, use your calculator to help. So in my calculator, because the base is 3, I would plug in 3 to the power of x, second graph, and I can go to my table and see that 3 to the 4th power gives me 81, so that means 4 is my answer. So then for the next one, we have 10 as the base now. So 10 to what power equals 100? 10 squared is equal to 100. And the next one, 8 to what power equals 8? So 8 to the first power is 8. So 1. Again, pause the video, see if you can do D and E on your own. When you're done, unpause and we'll check our work. So for this one, 5 to what power equals 25? 5 squared. So 2 would be the answer to this log. And if we keep going, 2 to what power equals 32? And again, if you don't know, go to your y equals. The base for this equation is 2, so it would be 2 to the power of x. Go to your table, and then you could see 5 is your answer. So 2 to the 5th equals 32. So 5. Because remember, the answer to a log is an exponent. So let's go ahead and evaluate these. So why don't you pause the video, see if you can do number 3 on your own. When you're done, you can unpause and check your work. So for question 3, 7 to what power equals 7? So this would be 1. 9 to what power equals 9? Again, that's 1. 11 to what power equals 1? The only time you can get 1 out for answer is when it's to the power of 0. And 10 to what power equals 1? So again, this would be 0. So why don't you pause the video and see if you can do number 4 on your own. When you're done, unpause and we can check our work. So for number 4, 2 to what power equals 1/4? Remember we said when we have a fraction, we know that the exponent has to be negative. So 2 to what power gives you 4? 2, so that means this has to be equal to -2. So 10 to what power equals 1/1000? So if you're unsure what gives you 1000 for 10, you could go to, again, your y equals and plug in 10 to the power of x, and then go to your table and you would see 10 to the power of 3 is 1000. So to get a fraction, that has to be a negative exponent, so -3. 5 to what power is 125? So again, if you don't know, you can go to your y equals, and we can plug in 5 to the power of x, go to our table, and we would see that 5 to the third is 125, and because it's a fraction, it's not just 125, it's 1/125. That means it has to be a negative exponent, so -3. And for the last one, 6 to what power equals 1/6? So 6 to the first is 6, but to get the fraction, we know it has to be a negative exponent. So 6 to the -1 equals 1/6. So again, remember when you have those fractions, that means that the answer is going to be a negative solution. All right, so looking at the next problem, question 5. So for question 5, why don't you pause the video and see if you can do these on your own. When you're done, unpause and check your work. So for the first one on number 5, we have 4 to what power equals 16. So we know 4 squared is 16, so 2. And again, if you don't know that, you could always go to your y equals, plug in 4 to the power of x, and then look at the table and see that 4 squared is 16. So 2 to what power equals 16? Again, same thing. We did this earlier, but if you don't know, you can go to your y equals and plug in 2 to the x and see that 4 would be the exponent, so 4 is the answer to the log. So log base 8 of 16, if we want to solve this one, 8 to what power equals 16? So we're not sure, so let's go to our y equals. So this would be 8 to the power of x. If I go to my table, notice that I don't get 16 for one of my values. So 16 is in between 8 and 64, which is an x value of 1 and 2, which is closer to 1. So I'm going to do some guess and check. So 8 to the power of 1.2, and we get 12. So let's do 8 to the power of 1.4. And notice that I get 18, so let's try 8 to the power of 1.3. And those I get 14. So for this one, you could either use 1.3, 1.4. If you wanted to come a little bit closer, you could say 8 to the power of 1.35. So I would accept either of those for now. So I'm just going to say 1.4. So then for the next one, 16 to what power equals 16? X would have to be equal to 1. So let's do the next ones. You can pause the video, try these on your own. When you're done, unpause to check your work. So 2 to what power equals 5? So again, we know that if we plug in 2 to the power of x, nothing's going to give us 5 for an answer, but 5 is in between a y value of 4 and 8. So the x values of that are 2 and 3. So it's going to be 2 point something. So 2 to the power of 2.2, let's say. So 2.2 gives me 4.59. So if I do 2 to the power of 2.3, I get 4.92. So that one's probably my answer. So 2.3. So 5 to what power equals 10? So again, in my y equals, I'm going to make this a base of 5. Go to my table. And so I'm looking for 10. Notice I don't have 10, but 10 is between 5 and 25. So I know my x values are between 1 and 2. So we have 5 to the, let's do 1.3. And I get 8. So 5 to the 1.4. gives me 9.5, and 5 to the 1.5 gives me 11, so I'm going to use 1.4. And keep going. So 6 to what power equals 1? 6 to the 0 power. 5 to what power equals 5? 5 to the first. 10 to what power equals 5? So then this one, if we go to our y equals and plug in 10, go to the table, notice that 5 is in between 1 and 10, so we know it's going to be a decimal between 0 and 1. So we could say 10 to the power of maybe 0.3. Let's do 10 to the power of 0.6 maybe. 10 to the power of 0.8. So maybe 10 to the power of 0.7. It's a lot of guess and check. So we get 5 there, so 0.7. So you can just keep plugging it in until you figure out the value of which it is equal. All right, so question 7. For this one, we would do the same thing. So 10 to what power would give us 50? And 10 to what power is equal to 150? 10 to what power is equal to 1,000? 10 to what power equals 500? So if you do these on your own and then unpause to check your work, for the first one, you should get 1.7. For B, you would get 2.1, C, 3, and D, 2.7. Looking at question number 8, now notice we have the log base 3 of 3 to the second power. So this is saying 3 to what power equals 3 squared. Remember when we solved something with the same base, we said we set the exponents equal. So that means that x has to be equal to 2. So this would be 5 to what power equals 5 to the negative 2? Well, x would be equal to negative 2, because when we have something with the same base, we set the exponents equal. So in this case, we get negative 2. 6 to what power equals 6 to the power of 0? So x equals 0. For this one, 4 to what power equals 4 to the negative 1? So notice x would have to be equal to negative 1. 2 to what power equals 2 to the third? X equals 3. So based on your work with logarithmic expressions, it says to determine the following statements are always true, sometimes true, or never true. If the statement is sometimes true, describe conditions that make it true, explain your answers. So looking for the number 9, it says the value of log base b of x is positive. So this is sometimes true. And we know that because think about if I do the log base 5 of 1 over 25. We know that if I want to solve this, the answer to the log is the exponent. So if I put this in exponential form, 5 to what power is 1 over 25? We know to get a fraction, we have to have a negative answer. So this is negative 2. Question 10 says log base b of x is not valid expression if x is negative. So let's try that out. So log of base 2, let's do of negative 4. We're trying to figure out what that's equal to. So the log base 2 of negative 4 would be 2 to what power equals negative 4. So remember, when I'm working with exponents, if I go to my y equals and I plug in 2 to the power of x, and I go to the table, notice that when I plug in negative values, I am not getting negative answers, right? I get answers closer and closer to 0 because remember, negative numbers as exponents become fractions. If I plug in 0 into my equation, notice I get 1, and if I plug in positive values, I get positive answers. So this is true. Log base b of x is not valid expression if x is negative. So this is true. We can't take the log of a negative number. For the next one, we have log base b of 1 equals 0 for any base greater than 1. So this is always true, because if I do log base 5 of 1, I would get 0 because 5 to the first power is 0. It works for any base bigger than 1. Log base b of b equals 1 for any base bigger than 1. So if I did log base 5 of 5 equals 1, this is true because 5 to the first power equals 5 when we rewrite it in exponential form. So true, sometimes true, true, true. And question 13, the log base b of b to the n equals n for any base b, and this is true because look at all these questions that we just did up here. So this is true because b to the power of n, when you do your loop trick, is equal to b to the n. And here, b to the first equals b. And for this one, b to the power 0 equals 1. So now we also have what's called the change of base formula. So the change of base formula, if you have the log of any base b of a, you can calculate this using your calculator in the change of base formula. This would be the log of a divided by the log of b. And so notice here I don't have a base written. When your base is not written, that is called a common logarithm, and it means it's actually a base 10. So let's go back to our graphic organizer. And in my graphic organizer that's on the back side, it says, oh no, my logarithm has no base. So when the base of the log is not written, that is a base 10, which is called a common logarithm. So if I have the log of x and the base is not written, this means it's a log base 10 of x. So if it helps you to write that 10 in, you can. So if I want to evaluate these, I can rewrite them with the base if I want. This is the log base 10 of 10. We're trying to figure out what that's equal to. So if I rewrite this in exponential form, 10 to what power equals 10? Well, we know this is equal to 1. For the next one, this would be log base 10 of 1/10. So again, if I rewrite this in exponential form, 10 to what power equals 1/10? We know to get a fraction it has to be a negative exponent, so this is equal to -1. And then again, if we put a 10 for the base, this would be 10 to what power equals 1,000, and we know that would be 3. So down here, when we use the change of base formula, this allows us to use a base 10 in our calculator. So this is a base of 10. So if I want to use the change of base formula here, this would be equal to the log of 9 divided by the log of 2. So this allows us to actually use our calculator to evaluate these. So in my calculator, if I use the change of base formula, I go to log 9, make sure you close parentheses, divided by the log, which is next to the 7 button, of 2, close parentheses, enter. And notice I get this is equal to 3.169, so 3.1, let's do 699. We'll round using 4 decimal places. So as before, we were saying 2 to what power equals 9 and doing guess and check to figure out what that's equal to. Now we can use our change of base formula to figure out a more exact answer. So same thing for the next one. We have log base 2 of 10. So we're saying 2 to what power equals 10. So remember we did this earlier. Up here we said 2 to what power is 10. We said about 3.3. So now we can use our calculator and the change of base formula to figure this out. So this would be the log of 10 divided by the log of 2. So the base goes down, and this allows us to use our calculator because notice the calculator doesn't write a base, so that means it's base 10. So this would be the log of 10 divided by the log of 2. Enter, and we get x equals 3.3219. And so what we put earlier, notice, was 3.3, so we were very close to the answer. when we just did guess and check. So this is just a more exact answer. So then for the next one, same thing. This would be equal to, using the change of base formula, log of 150 divided by the log of 2. And again, always make sure you use parentheses when you plug these into your calculator. So we have the log of 150, close parentheses, divided by the log of 2, close parentheses. And the reason I tell you to close your parentheses, because if you don't close the parentheses, like if I left that parentheses off right there, your calculator is going to give you a different answer, so be very careful. So 7.2288. And of course, you can always check your work. If I do 2 to the 7.2288, that should be about equal to 150. It might not be equal to 150 because we rounded. So 2 to the power of 7.2288, you'll notice that that is equal to about 149, again 0.99 because of rounding error. So properties of logarithms that we are going to be using and should know are these two properties right here. If I have the log base b of b, I know that's going to be equal to 1. Why? Because b to the first power equals b. Over here, b to what power would be equal to 1? This would be 0, because b to the 0 power is 1. So that is all for our logarithmic notes for today. Notice over here in your graphic organizer, I also put those two properties, and also there's the change of base, so you might want to add that in. This is the log of a divided by the log of b. And that is all for the notes for today.